Thank you very much. Thank you for coming for the last technical session of the day, and thank you for your patience. My name is Angelo. I'm a solution architect from Brazil, specialized in big data. So today, we are going to talk about how to build data lakes and analytics on AWS. Every organization generates data, right? So the challenge is how to get value from data. If you can get value from data, you can take smart decisions that are going to help your organization to grow, right? This interesting survey was did by Aberdeen, shows that organizations who have deployed a successful data lake, they grow 9% more than organizations who cannot bring insights from their data, right? So that's the challenge, right? In order to get this value, you have to find the right tools, the right people. So traditionally, analytics used to look like this, right? Traditional data warehouses. So you have your ERP, your CRM, you start extracting data from it and ingesting into a big data warehouse, right? Then you plug a business analytics tool, and then you start getting information, right? So this strategy still works, right? But technology is evolving, right? So because of that, in the last years, we started proposing this new paradigm called data lake, right? So data lake is not a replacement, but an extension to the traditional approach, right? So we are still getting data from the CRMs, from the ERPs, and ingesting into some database or analytics engine. But now we have new challenges, right? So we don't want to analyze only relational data. We want to analyze non-relational as well. Also, we want to scale more. We want to ingest more data. Because in the past, you used to get data from CRMs and ERPs. Now, we are getting data from mobile, from web applications, from social media, and even from sensors, if you have IoT implemented within your organization, right? So, new challenge. We are ingesting more data, right? So we need to scale more. Also, technology is evolving. So we don't want to use only one engine. We want to use many engines, right? Every single analytics engine provides different capabilities, right? So we want it all. We don't want to keep to a single engine. And we have machine learning, right? So machine learning, it's evolving. We want to apply machine learning on top of our data. So here comes the data lake. First thing, right? The core of our data lake is not anymore a relational database. So now we are using a simple storage, right, that is really cost-effective and really scalable, right? So on AWS, we have a service called Amazon S3, which is a simple object storage, right? So we start ingesting data there. So it's not just, again, it's not just relational data. We are bringing all kinds of data, structured and non-structured. We are bringing images, we are bringing audio, and many other kinds of data, right? So this is just beginning. We also have to add more tools in order to help us to ingest the data in real time or data from on-premises. We have to plug analytics engines and also machine learning, right? And then we have the high level of our architecture for data lake. So AWS provides a set of tools, right, that are gonna help us to reach this challenge. We don't have time to talk about all the tools. So today we're gonna focus in a few of them. So let's start with AWS Glue. AWS Glue is an ETL service where you can do extraction, transformation, and loading of your data. But also, AWS Glue provides many different capabilities. The capability I'm going to talk about is about a central catalog, right? Because now we have a central storage. We're putting all our data into a central storage. And this central storage can accept many different formats for data, right? So it's also important to have a central catalog, because since we are going to change from one analytics engine to many different analytics engines, it's important that all those engines will access the same catalog, right? Because this is going to make our lives easier. So this is more or less an example of a flow. So on the left side, you can see many different data sources, right? So we are going to send data to Amazon S3, which is the core of our data lake. And then we will start using Glue in order to verify the data and try to guess or extract metadata from data, right? So Glue is going to help us with that. And then after that, Glue is going to catalog the data. And then the data is ready to be consumed. How do we populate the data, the catalog, right? So we can do manually. So we have a wizard, the web console. We can also run a Hive DDL statement. It's like a create table in SQL. We can use the API, so you can integrate with different tools. And also, since Glue is an evolution of the Hive meta store, if you have a Hive meta store in your organization, you can export and import to AWS Glue. So now, I'm going to switch to my demo, to my computer. And see and show how it works, right? So right here, I have a spreadsheet. Yesterday, I was searching in the Colombian open data portal, right? And try to find some interesting data, right? I know that you Colombians, you love coffee, but we Brazilians, we love many things, but we love rice. We eat rice every day, right? So I downloaded a file with a lot of information in terms of how many the banks, the Colombian banks, have invested in the rice plantations during 15 years or more, right? So that's here. It's a CSV file. So this is not an Amazon proprietary standard, right? So this is open standard, CSV file. So first step, we are going to upload this file to S3, right? So this is going to be the data ingestion. So now we have the AWS console, right? I go to S3 and I have a bucket called My Hive Sandbox. And I'm going to create a folder. You can give whatever name you want. I'm going to give the name of investments, right? So investments in rice. And this is like just a folder, right? Okay. So I'm going to open this folder and upload a file. So I have a file here called arroz. It's hard for Brazilians to say arroz because we say arroz in Brazil, but I'm trying, okay? So this is a big file. Let me upload it. It's 11, here it's 11 megabytes, but we can go exabytes. Doesn't matter, right? Of course, in the real world, you would add some scripts to do it manually, automatically for you, right? You're not going to upload data manually. But that's what you're going to do for the demo today. So 50%. So this is the ingestion phase, right? This is the first phase of big data applications. We are ingesting data. There are many tools that can help you to do that, right? And we have many different tools, but this is not the focus of the presentation today. All right, so we have the file. Now it's time to go to Glue, right? So we have the data, but now we need the metadata, right? So I'm going to Glue, and I'm going to create a database. This database is going to be a central database that can be accessed by many different analytic engines, right? So I'm going to call it Bogota, just a name. And then I can create the table manually, but Glue has a functionality called crawler. So you can add a crawler that will try to guess the metadata from the data, right? So I'm calling this crawler Bogota, and I'm going to specify the path of my data, which is a bucket on the S3 in a folder called investments. Let me refresh here. Okay, so we have a folder called investments with a file called arroz, right? And that's it. Now we are going to hit next. Next. We select a security role in order to get us access to the data. Next, run on demand. And then I'm going to select the Bogota database, right? So I want every table to be created into this database. Next, finish, and run it, right? So I'm going to run it. This is going to take like 2 minutes. So now we are going to get back to the presentation, and then we can get back to the demo later. All right, so next step. I have the data. In 2 minutes, I will have the metadata. Now I have to get value from data, right? So I need some kind of analytics engines, right? So let's get started with Amazon Athena. Amazon Athena is like a service, interactive service, where you can do SQL queries on top of data from S3, right? So we don't have to install a relational database. Under the hoods, we have 2 very popular open source frameworks. We are using Apache Hive and Presto, right? So Hive is going to be used for the DDL, for the creation of the tables, and Presto is going to be used for the queries, right? For the SQL queries. And having those 2 frameworks as a service, you don't have to handle any servers. Just use it as a service, right? You don't have to install software, you don't have to do anything. So really, really fast to get started with Athena. Right? So going back to our process, we did the ingestion to the S3. We run the crawler. Now we have metadata. Now we are going to plug the first analytics service, Amazon Athena. So please get back to the demo. And let's go to Athena. So this is the Athena console, right? I'm going to do a zoom here. And then I'm going to refresh and try to select the database Bogota. So here it is, right? So I have database Bogota, and I have a table called investments. This table was created by the Glue crawler, right? So first thing, I'm going to preview this table and run a SQL query. That's it, right? So I have a result set, ano, mês, clase de crédito, fuente de colocación, the bank who has invested, and many other columns. It's like a table in a relational database, but in fact, it is not. Just a file on S3, and we are loading this file into memory in order to accelerate the queries. All right. So let's go back to the demo session. Sorry, to the slides. And then I have data. I have metadata, and now I can start doing analytics, right? So I have Athena. After I start doing my SQL queries, right? I can plug different engines. So who here is familiar with Apache Hadoop? Many people. So Apache Hadoop started many years ago as a framework for distributed computing, but now it's a whole ecosystem. Many different frameworks around Apache Hadoop that can help us to do analytics, right? So, but this is really, really complex because it involves a cluster. So it's not easy to create, configure, and maintain a cluster running the Apache Hadoop and Spark ecosystem. So we created a service called Amazon EMR that help you guys with this task. So with 2 clicks, you can launch a cluster and starting running different frameworks such as Hive, Presto, Spark, and many others. You can run machine learning. You can run MXNet here, and you can run many other different frameworks. Right now, it's more or less 20 different open source frameworks that you can use on top of your EMR. So EMR is like a Swiss knife, like a jack of all the trades that can help you to do many different tasks on top of your data. When you work with Hadoop ecosystem on premises in your own data center, usually we use traditional storage, commodity disks. On AWS, we use S3, because when you use S3, when we decouple computing from storage, our life gets really easier. Because in order to use EMR, you don't need to run a cluster all the time during the whole day. You spin up a cluster, you do your processing, you terminate the cluster, because the data it is not in the cluster. The data is on S3, right? And in terms of economicals, right, you're going to save a lot of money if you work with using this paradigm. You can use persistent clusters as well, and never turn off the cluster. But transient clusters is a really good way to save money working with big data and data lakes. Also, Athena uses Glue Catalog, and EMR also uses the Glue Catalog, right? So now, in our example, we have Athena and we have EMR running many different clusters, frameworks, sorry, on top of our data on S3. So let's get back to the demo, right? And do some queries on top of Athena. So here, so let's see what banks are investing more money, right? So it's going to be Bogotá.investments, right? That's it. All right, so this query is a SQL query, SQL ANSI, because Presto supports SQL ANSI. And let's see. Let's see what are the top 10 banks that invested in rice plantations in the last year in Colombia. So BBVA Bank invested 41 billion pesos colombianos just last year, right? If you get all the 15 years, it's like trillions of pesos colombianos. Banco Agrario de Colombia was the second investor, invested 36 billions, right? And you can vary your queries and start extracting different information from here. Right, so SQL is part of the solution, right? But let's say, so now we have data, we have metadata, we have our first analytic engine connected to this data. And I can run some SQL, right? And let's plug our second analytics engine, which is a different product from AWS called Amazon Quicksite. So Quicksite is a service where you can connect to different data sources, right? And start creating reports and dashboards. And you can even use machine learning if you use Quicksite in order to generate your reports. So let's create a data source pointing to our data lake. So I'm going to create a new data set. And now I have to pick the data source type. So I can connect to S3, to Athena, to RDS, to Redshift, to MySQL, Postgres, MariaDB, Oracle, and many other solutions, right? So I'm going to select here Athena, right, and give it a name. So the name is going to be Bogota. Okay. So next step is to select the database from Athena and the table. So I select the database called Bogota and the table called investments and select. Now, when you use Quicksite, you can do your queries direct to your data source, or you can load all the data in memory in order to speed up the queries, right? So we call this spice. This is optional. So here I'm going to connect directly to my data source, to Athena. So Athena is going to be doing the hard work, the heavy work, and doing the queries. So let's visualize. And of course, you can import many different tables. Here, I'm importing only one table. So this is the first page of the Quicksite. This is called autograph, right? So first thing, autographs kind of try to guess what kind of information you are trying to put into your dashboard. So first thing I'm going to do is to click at the value in the investments table, right? So basically what autograph is analyzing is, okay, this is a number, right? So this guy is doing analytics, right? So he probably wants to know the sum in terms of investment. Okay, this is how much was invested in Colombia by the banks just to finance rice plantations in the last 15 years, according to the open data portal from the government. I can even read this number. I think it's 2 trillion Colombian pesos, right? Great, but let's make it better, right? So let's try to group this by bank. So I want to know which bank invested more. So let's say, so I'm going to select a field called intermediario, who is apporting money, right? And now we have here the sum of the investments by bank. So I know that Banco Agrario de Colombia was the top investor by far. Second bank was BBVA. All those guys are helping Colombia to produce rice. Great. So we can make it better. So let's say we are going to group also by rice type, the kind of rice, because you know there are many kinds of rice, and I want to know who is investing in different kinds of rice, right? So I can see here that Banco Agrario de Colombia is investing in 1, 2, 3, 4, 5 kinds of rice. So in terms of diversity, Banco Agrario de Colombia invests in more kinds of plantations. Most of the other banks, they're investing in the top 2, which is arroz riego y arroz secano, right? And then we can see how the banks are diversing their investments, okay? Great, so this is Quicksite. Quicksite can help you to do your analytics. If you have your own tool, your preferred tool, you can bring it to AWS and connect to all those data sources as well, right? So everything is configurable and you can connect whatever you need. Great, so can you get back to the presentation, please? Awesome. So I have data. I have metadata. I have, at this moment, 2 different analytic engines, right? Presto for Athena, and we have also Quicksite. And I can even connect more engines. I have their EMR cluster, right? But I don't think I'll have time to show you. So next step, in the evolution. Machine learning. Why not use machine learning on top of our data lake, right? And then we can start doing even more complex analytics on top of our data. So AWS offers many different solutions for machine learning. So first one we can talk is on the infrastructure level. So let's say you are really experienced in TensorFlow or Apache MXNet or any other open source framework like PyTorch and Caffe, for instance, and you want to run it on AWS. So we have an image, right? A pre-configured image with all those frameworks already configured and optimized to run on top of AWS. So you can spin up a virtual machine, and you can use a traditional virtual machine with CPUs, or you can go faster. You can spin up a virtual machine with a GPU. If your model can scale and process and train your model in parallel, you can use GPU to accelerate the process even more, right? So this is a simple way to get started. Just a virtual machine with a pre-configured image. But you can also use platform, right? Because we have many different services where we can add more than a single virtual machine. For instance, Amazon SageMaker. Amazon SageMaker is a complete platform that can offer you a notebook, for instance, and that can train your model and deploy your model to be consumed as an API by you or by your customers, right? And also, if your team doesn't have any knowledge in terms of machine learning, you can use our application services. These application services are machine learning applications where we train the model, and we write the algorithms, and then you don't have to program anything. You just integrate your code with our APIs, and you can start doing machine learning, right? So for instance, we have Amazon Recognition that can recognize video or images. We have Amazon Transcribe that can transcribe audio into text. We have Amazon Comprehend that can analyze text and extract insights from text. So many different solutions depending on what you want to do. And all that you can do on top of your data lake. Remember when I said data lake is not just about structured data. Now we have audio, we have images. So you can start doing new things. We can start doing innovation. So again, SageMaker, you have notebook instances. You have a lot of predefined algorithms, but you can bring your own algorithm, right? So this is based on container technology, so you can customize a container with your own framework and deploy on top of SageMaker. We train your model to you, and we deploy the model to you so you can offer this model as an API to your customers or internally within your company. So going back to our model, so I think we covered it all, right? So we ingested data into S3. We use the crawlers to extract metadata. We apply Athena, EMR, and other tools, other engines to run analytics. And then we can add SageMaker or any other tool in order to extract machine learning insights. Great. So now we have a customer in Brazil. They're called Impe, right? So they're doing really, really nice things on top of AWS using analytics to solve really, really complex problems, right? So now I'm going to call Mauro Assis from Impe, and he's going to tell you guys a really, really interesting story. Thank you, Mauro.
Well, I'm Mauro Assis, and I work for an institute called CCST, the Earth System Science Center. We are part of the Brazilian Spatial Agency, And our strategic goal is to look to climate variables, to climate, in a perspective of relation with people, with water availability, with forestry. And the idea is to understand the Brazilian climate, but looking from a global perspective, as climate is global. The question that we faced was, how much does Amazon forest weight? Okay, but the previous question, okay, how much, why to map Amazon biomass? To explain that, I will have to contextualize for you.
Se você for olhar, a floresta amazônica vem da atmosfera, né? Toda ela. Chega do ar a água, o alimento, o CO2. O CO2 é a matéria-prima principal das plantas. É o CO2 que toca todo o sistema.
A floresta, nesse processo natural da fotossíntese e respiração, ela tira CO2 da atmosfera e fixa nas árvores.
Então a gente olha para uma árvore, olha aquele ser maravilhoso em frente da gente, o que a gente vê é o estoque, é o que sobrou entre o que ela absorveu, o que ela metabolizou e o que ela estocou.
A Amazônia detém um estoque de carbono absolutamente crítico para o clima futuro do nosso planeta.
O que o projeto, por exemplo, busca, né, é contribuir ao entendimento, ao longo dos anos, da quantificação desse estoque. Quanto melhor a gente sabe o quanto que tem de biomassa e carbono num determinado ecossistema florestal, melhor a gente estima as emissões.
Um ponto super legal desse projeto é que eles estão tentando melhorar a estimativa de biomassa com esse dado de LiDAR, né, que é um laser, né, que é aerotransportado. E esse laser ele te dá informação sobre a altura do dossel, né, da floresta, e ele permite que se façam reconstruções tridimensionais da floresta.
O que a gente está buscando com essa tecnologia, essa metodologia, e através do desenvolvimento desse projeto, é contribuir para a redução da incerteza dessas quantificações.
E entender a estrutura da floresta, né? E isso vai ter interações com diversos aspectos de políticas públicas, né? Ou de mudanças climáticas também, da ciência de mudanças climáticas.
Esse projeto permitiu uma coleta de dados muito grande, é a maior base de dados do mundo em florestas tropicais.
So that was the challenge, that is to process the greatest database Forrester Database in the world. So those are some numbers. We have 68 million pixels, covering 4 million square kilometers area. We did 1,000 flights over the forest, but these flights, 1,000 flights, covering only 0.04% of the Amazon area, okay? So it's just a sample of data. And we have a lot of satellite data to process as well. And we have a machine to process that, okay? It's a good machine. We use random forest algorithm and Python using H2O implementation of random forest. We use LiDAR. LiDAR is a laser scanning, that is. We used to scan forest by laser, and scanning that from a plane, we produce a 3D modeling of the forest. LiDAR is the only sensor that allows us to get the vertical structure of the forest, okay? And of course, the biomass is distributed vertically, and so it makes sense to use LiDAR because of that. The process is quite simple. We went to the field and collect some data. Then we fly with the LiDAR sensor over that areas that we know the biomass. And we create a model that, based on LiDAR, estimates the biomass below the area we flew. Then we use satellite to extrapolate the data, the LiDAR data, the biomass data, over the area that we don't have any flight data. This is the biomass map of the Amazon. This is the result of the main result of our research. But we need more. We would like to know how much we are not secure about the values, okay? And so we would like to propagate the error since the field measurement until the whole estimative of the biomass. This is a far greater effort in terms of computation, because I have to generate 1,000 maps, and we don't have resources to do that. And so how to do that? The answer was analytics process in AWS. We contact AWS, and they presented us a partner, that data rain. We did 2 proof of concepts, and we used 4 EC2 instances with Linux 64 cores and 1 terabyte of random memory in the 4 machines. We use Python. We divide the area in 16 areas, so each server processed 4 areas. We run during 40 hours, 2 guys to operate. I think I slept about 2 hours in that 40 hours. And we create 1,000 maps, and then I get these 1,000 maps downloaded and summarized in my machine. That took 2 days to summarize the map and obtain the results that we need. The AWS service that we used was EC2, S3, VPC for security, outscaling, and marketplace H2O. This is a third-party tool that implements the random forest algorithm that we used. This is the uncertainty map, and so, as you can see, as more red is, the errors is greater. So now, we know what we don't know about biomass in Amazon. That's the result, the final benefit of the project, okay? The main benefit was the biomass, the uncertainty map itself, that is, it wasn't possible to obtain this map without the Amazon, the AWS resources. The data rain AWS support is amazing for us. It helped us a lot to find alternatives in terms of our needs. It was the first time that INPE, our spatial agent, used cloud services. So for us, it was an interesting experience. The map, we got the map, and we have a very nice return of investment. In terms of return of investment, each LiDAR flight costs $2,000, okay? We did 1,000 flights. So we have $2 million of flights. Now, instead, when of course, the biomass is changing in Amazon, okay? So I have to improve I have to update the map in 2 or 3 years. Now, instead of flying to get 1,000 flights and spend all this money again, it's possible to do only 150 flights. And so the costs will get far less than we spent this process to generate this map, okay? And we saved, next time that we create the map, instead to spend $2 million, we will spend only $1.5 million. So the return was very nice. That is, we spent $10,000 and are earning for Brazilian society 1.7 million. And so, that's it. Thank you.
All right, so final message, right? Agility and innovation are key, right? So in traditional data warehouse architectures, you have to buy huge servers, huge amount of storage. And many times you have only one analytical engine. And the guys from NIMPI, they needed hand-on cut forests, right? It's one kind of function for analytics. I can assure you, most of the relational databases, they don't have this, right? So when you have this agility, so you can spin up servers in 10 minutes, you can use a marketplace from AWS with a pre-installed solution from our partners, or you can use our own solutions. You can spin up your environment in just a few minutes, as I did right now. I uploaded data, cataloged the data, plugged 2 analytical tools, and start doing analytics, right? In 10 minutes. Those guys, they did it in 1 day. I mean, the POCs, and then they do in 2 or 3 days, they process all the data. And guess what? After that, they terminated the instances. They're not spending any cent right now. They're going to spend more money in 2 or 3 years after they do the next flights. So agility, innovation are keys, right? So we can help you to solve this hard challenge.